Hi students, in this section we'll see an interesting method with which you can find the last two digits, and finding the last two digits question is the same as finding the remainder when you divide the given number by 100. Alright, let's see some of the questions. You may get a question like find the last two digits of 31 to the power 125 or 733 to the power 56, 695 to the power 78, 74 to the power 288 or 2 to the power 786. So these are some example problems. So you can see that these type of questions are of the form x to the power y. So you have x to the power y and you are asked to find the last two digits, or you may be asked to find the remainder when x to the power y is divided by 100. Both are the same. Both are the same type of question. Now, to solve this, let's classify the type of problems. There could be a case where the x over here, this number over here, or the base of the exponent could be odd or it could be even. So we'll classify it like that. And in the case where x is odd, it could end with 1, or the number could end with 3, 7 or 9, or it could end with 5. So we'll classify it like this, and we'll see how to find the last two digits in all these four cases. Now, what's an example where it's ending with 1? It could be something like 31 to the power 78. Over here it could be 33 to the power 78, or 37 to the power 78, or 39 to the power 78. And over here it could be 35 to the power 21, right? These are few examples. And the case where it's ending with an even number, it could be something like 36 to the power 29. All right. Now let's take up all of these one by one, and we'll start from here. All right. We have classified the problem of x to the power y into these four scenarios, and we are starting with the case where x is odd and x is a number ending with 1. Let's take an example. Say you want to find out 31 to the power 125 and you're asked to find the last two digits. So you want to find the last two digits when you do this operation. All right. Now, whenever the last digit is 1, like it's over here, you can be sure that the last digit that you get over here also will be 1. All right. Now, you also need to find this digit over here. For that, take the second last digit over here, that's 3, and multiply it with 5. That's the last digit of the power. So multiply 3 and 5. 3 into 5 is 15. So write the rightmost digit of this. This is 15. The rightmost digit is 5, and that will be the digit that you get over here. Therefore, 31 to the power 125 will end with 5 and 1. This will be the last two digits of 31 to the power 125. You can do this just in 2 seconds. All right, let's do some practice. Say you want to do 121 to the power 72. Again, over here the last digit is 1. Therefore, this digit over here also will be 1. Now, to find this digit, take 2 and take this 2, multiply these two. 2 into 2 is 4, and that's your answer over here. The last two digits is 4 and 1. Say you want to do 81 to the power 1427. Over here you have 1, therefore you have 1 over here, and 8 into 7 is 56. So you write 6 over here. Therefore your last two digits of 81 to the power 1427 is 61. We have covered this case where x over here is odd and it's ending with 1. And for example, we have seen 31 to the power 125 will end in 51. All right, we move on to the case where we have the number x ending in 3, 7 or 9. In this case, you need to change the number to a number that ends in 1. Now, let's see how we can do this. We can observe that 3 to the power 4k, 7 to the power 4k and 9 to the power 2k will end in 1. So for example, what's 3 to the power 4? That's 3 into 3 into 3 into 3, that's 9 into 9, which is 81. You can see that 3 to the power 4 is 81 and it's ending in 1. Similarly, 3 to the power 4k, 7 to the power 4k, 9 to the power 2k will end in 1. Alright, let's take an example to apply this what we've learned now. Say you want to find the last two digits of 237 to the power 56. Now, over here, this digit over here does not matter because the last two digits of an expression will only depend on the last two digits. Therefore, the last two digits of 237 to the power 56 and the last two digits of 37 to the power 56 will be the same. Alright, now let's write that over here. We just need to find out 37 to the power 56. Alright, now over here we have mentioned that 3 to the power 4k will end in 1. Right, now let's see how many multiples of 4 are there in 56. So I can write 56 as 4 into 14. Right, it's a perfect multiple of 4. 4 into 14 is 56. Therefore, I can write 37 to the power 56 as 37 to the power 4 to the power 14. Why is that so? Because a to the power m to the power n can be written as a to the power mn. So I have written 37 to the power 56 as 37 to the power 4 to the power 14. Alright, now let me simplify this. I can write this over here as 37 square into 37 square to the power 14, right? I've written 37 to the power 4 as 37 square into 37 square. Now, we are only interested in the last two digits, and there's an interesting thing that you can note over here. 37 square, 13 square, 63 square, 87 square, 113 square, 137 square, all will have the same last two digits. So what is this set of numbers? Over here, say you have 13, that's this one over here, 13 square. If you do 50 minus 13, you will get 37. That's 37 square over here. If you do 50 plus 13, you will get 63. That's 63 square over here. If you do 100 minus 13, you will get 87. That's 87 square over here. If you do 100 plus 13, that's 113. That's your 113 square over here. So in this manner, you can note that 13 square, 37 square, 63 square, 87 square, 113 square all will have the same last two digits. And you can verify this using the method that we've learned before to square any number. We know 13 square is 169. What's 37 square? To get the last digit, you have to do 7 square, that's 49. You write 9 over here, 4 gets carry forwarded. 3 into 7 into 2, that's 21 into 2, that's 42. 42 plus 4, that's 46. And 4 gets carry forwarded. 3 square is 9. 9 plus 4 is 13. So you can see 13 square ends in 69. Similarly, 37 square also will end in 69. And if you find 63 square and 87 square, you will see that these two also will end in 69. And over here, we are only interested in the last two digits. So instead of 37 square, let me write 69, and instead of 37 square over here, I'll write 69. So when it comes to the last two digits, I can rewrite this as 69 into 69 into 14. And remember, this is not exactly equality. It's just about the last two digits, right? That's why I can just write 69 into 69, because we have seen last two digits will only depend on the last two digits. Therefore, this expression over here is rewritten as 69 into 69 to the power 14. 169 stands for 37 square. The next 69 stands for this 37 square. Alright. Now 69 square will have the same last two digits as 19 square, because 69 is equal to 50 plus 19, right? Therefore, using the same thing that we've seen over here, you can notice that 69 square and 19 square will have the same last two digits. Similarly, even 50 minus 19, that's 31. 31 square also will have the same last two digits as 19 square, will have the same last two digits as 69 square, that will have the same last two digits as 100 minus 19. What is 100 minus 19? 81. So 81 square also will have the same last two digits as 69 square. Alright, let's move on. So over here we have 69 square to the power 14. Let me make some space over here. Alright, let's move on. So we have seen that 69 square will have the same last two digits as 19 square. Now 19 square is 361. So instead of 69 square, I'll just write 61, right? And then I have a power of 14. I have a power of 14 over here. So I write 14 over here. And remember, I can write it like this because I'm only taking the last two digits, because last two digits depends only on last two digits. Now 61 is a number that's ending in 1, and we know how to find the last two digits of this expression. It will end in 1, and to get the second last digit you have to multiply 6 and 4. That's 24. So you take 4 from that. Therefore the last two digits of 61 to the power 14 is equal to 41. And that's your answer. We have found that 237 to the power 56 will have the last two digits as 41. Let's do this problem. You have to find the last two digits of 33 to the power 257. Alright. Now, in this case, you can see that the last digit over here is 3, and we have to use the method that we have learned in case the last digit over here is 3, 7 or 9. Now that says that 3 to the power 4k, 7 to the power 4k and 9 to the power 2k, right? These will end in 1. So because it's 3, you have to do 257 divided by 4. If it was 37, say this question was 37 to the power 257, still because over here we have 4, you still have to see how many 4s are there in 257 and take any remainder that remains. And in case it was 9, suppose it was 39 to the power 257, you should have seen how many 2s are there in 257 and what remainder remains. Alright, now let's move on. Over here we have 33 to the power 257. Now I can write this as 33 to the power 4 to the power 64 into 33, right? Why is that so? Let me make some space over here. That's because 257 is equal to 4 into 64 plus 1. And why are we taking 4 over here? It's because 3 to the power 4k ends in 1, right? So that's why we take 4. If this question was, again let me repeat, 39 to the power 257, you would have written 257 as 2 into something plus 1, right? Because in the case of 9 we have 2k over here, so you have to take 2 over here. Alright, let's move on. So we have rewritten 33 to the power 257 as 33 to the power 4, the whole to the power 64 into 33, right? Now, and the reason is 257 is 4 into 64 plus 1, and this is the same as 33 to the power 1. Alright, now let me write this as 33 square into 33 square to the power 64 into 33. And I am only interested in the last two digits. The last two digits of 39 square will be the same as 17 square, right? So 33 square has the same last two digits as 17 square. We know 17 square is ending in 89. So let me write this as, for this 33 square I write 89. For this 33 square I write 89. So 89 into 89, that becomes 89 square to the power 64 into 33. And remember, this is all about the last two digits. Now over here I have 89 square. We know that 89 square is 100 minus 11, right? Therefore 89 square and 11 square will have the same last two digits. 11 square is 121. Therefore instead of 89 square, I can write the last two digits, which is 21. So this becomes 21 to the power 64 into 33. Now over here 21 is a number ending in 1, so we know the last digit over here will be 1, right? And then you have to multiply 2 with 4, that gives you 8. So this simplifies to 81 into 33, and let me make some space over here. To find this you just need to do the multiplication. Alright, we have some space over here. So 81 into 33, you can see it is 2673, and your last digit over here is 7 and 3, last two digits. Therefore the last two digits of 33 to the power 257 will be 73. So far we have covered these two cases where x is ending in 1 and where x is ending in 3, 7 or 9. Alright, now let's see this case where x is ending in 5. Say you have a number ABC 5. and if it's raised to an even power, so this could be any number, for example 2375 raised to 20 or 22, any even power, this type of a number always will end in 25. So your last two digits will be 25. All right. Now, if you have a number ABC 5 to the power odd, you have an odd power, for example 2 3 7 5 to the power 19, right? Over here you have an even power, over here you have an odd power. In this type of a case, you need to do one more check. You have to see whether the previous number that's over here, C, if C is even, the last two digits will be 25. If C is odd, the last two digits will be 75. So what would be the last two digits over here? You can see that the power is odd, it's 19. So you have to check the previous digit, that's 7 over here. 7 is odd, therefore the last two digits of 2375 to the power 19 would be 75, right? So in what are the cases where you can see the number ending in 25? Let's summarize. You can see if the power is even, it'll end in 25, and if the power is odd but C is even, right, it will end in 25. All right. If the power is odd and C is odd, you will get 75 as the last two digits. Hi students, we have covered the cases where X was an odd number, that is ending in 1, ending in 3, 7 and 9 and ending in 5. Now let's move on to the case where the number X over here is an even number. In this case, we use a technique that says 1024 to the power even will end with 76, and 1024 raised to an odd power will end in 24. And remember, 1024 is nothing but 2 to the power 10. Alright, let's keep this aside and see how we can use this. Alright, say you are given a question 2 to the power 286 and you are asked to find the last two digits. Alright, now 2 to the power 286 can be rewritten as 2 to the power 10 to the power 28 into 2 to the power 6, right? Because 286 can be written as 28 into 10 plus 6. Based on this, we have rewritten 2 to the power 286 as 2 to the power 10 to the power 28 into 2 to the power 6. Now, from this rule over here, we know that 2 to the power 10 to the power 28. 28 is an even number, right? So when 2 to the power 10 is raised to an even power, it will end in 76, right? Therefore, the last two digits over here will be 76, and 2 to the power 6 is equal to 64, right? If you multiply 2 6 times, you will get 64. What are the powers of 2? 2 into 2 is 4, 4 into 2 is 8, 8 into 2 is 16, 16 into 2 is 32, and 32 into 2 is 64. That's why 2 to the power 6 is 64. So this simplifies to 76 into 64, and that will end with 64, right? I am only concerned with the last two digits. Remember, last two digits only depend on the last two digits. That's why for this expression I can write 76 because the last two digits of this expression will be 76. Similarly, over here the last two digits is 64. The whole number is 64 in this case only, but I am only required to consider the last two digits. And then if I do 76 into 64, if you do the multiplication, you will see that your answer will end in 64, and therefore 2 to the power 286 will end in 64. The last two digits will be 64. Now you don't need to do this multiplication over here. Even to make this even faster, you can see that if you multiply 76 with 04, you will get an answer with the last two digits as 04 itself. Similarly, if you multiply 76 with a number of the form 4x, the last two digits will depend only on that number. So what do I mean with that? Say for example 76 into 4 into 8. 4 into 8 is 32. So the last two digits will be 32 itself over here. Similarly, over here you can see 76 into 64. 64 is nothing but 4 into 16. So if you do 76 into 64, the last two digits will be 64 itself. Let's take some more examples. If you do 76 into 8, right? 8 is 08. Your last two digits will be 08 itself. Or if you do 76 into 12, that's 4 into 3, right? Your last two digits of the answer will be 12 itself. So what is 4 into 5? That's 20. So 76 into 20. Your last two digits will end in 20 itself. Even if you do 76 into 220, last two digits only depend on last two digits. So you just need to consider 20 over here. This also will end in 20 itself. Let's do this question. Find the last two digits of 26 to the power 288. Alright. Now I can write 26 to the power 288 as 2 to the power 288 into 13 to the power 288, right? Why is that so? Because if I have AB to the power 4, I can write it as A to the power 4 into B to the power 4. Using this rule, 26 is equal to 2 into 13. So I am writing 26 as 2 into 13. Therefore, this expression becomes 2 to the power 288 into 13 to the power 288. Now let me find the last two digits in each of these and I'll multiply to get the answer. Alright. Now 2 to the power 288, I can rewrite it as 2 to the power 10 to the power 28 into 2 to the power 8, right? Because 288 can be written as 28 into 10 plus 8. Now 2 to the power 10, when you raise that to an even power, the last two digits will be 76, right? And 2 to the power 8 is nothing but 256. So this simplifies to 76 into 256, and I'm only concerned with the last two digits. Therefore, I just need to multiply 76 and 56. And remember, if you multiply 76 with 56, your last two digits will be 56 itself. Why is that? Because 56 is nothing but 4 into 14. Alright, so over here we have seen that 2 to the power 288 will have 56 as the last two digits. Alright, let me make some space over here. Now let's take this part over here. 13 to the power 288. I can write this as 13 to the power 4 to the power 72, right? And remember, why am I taking 4 over here? It's because 3 to the power 4k will end in 1. Alright, we have seen that before. So I'm writing this as 13 to the power 4 to the power 72. Let me write 13 to the power 4 as 13 square into 13 square to the power 72. 13 square ends in 69 because 13 square is 169. So let me write 69 for this and 69 for this expression over here. So that's 69 into 69 to the power 72. 69 square, remember, will have the same last two digits as 19 square because 69 is 50 plus 19, right? And 19 square is 361. Therefore, 69 square will have 61 as the last two digits. So I write this as 61 to the power 72, right? And when I take 61 to the power 72, the last two digits will be, because it's 1 over here, it will be 1 over here. And then 6 into 2, that's 12. So I write 2 over here. So 61 to the power 72 will have 21 as the last two digits, right? Let me make some space over here. Now I know that 2 to the power 288 ends in 56 and 13 to the power 288 ends in 21. Therefore, if I want to find the last two digits of this expression, all I need to do is I need to multiply 56 into 21, right? We make some space over here. Now 56 into 21 is 1176. If you multiply 56 with 21, you can see you'll get 1176. So the last two digits of this is 76. Therefore, the last two digits over here will be 76. Therefore, 26 to the power 288 will have 76 as the last two digits. Let's do this question. You need to find the last two digits of 2 to the power 97. Pause the video, give it a try, and then we'll do it together. Alright, we are back. I hope you have given it a try. So I have 2 to the power 97 over here, which I can write as 2 to the power 10 to the power 9 into 2 to the power 7, right? Why is that? Because 97 can be written as 9 into 10 plus 7. Alright, based on this, I have rewritten 2 to the power 97 like this. Now, we know that 2 to the power 10 when raised with an odd power, this is an odd number, right? 9 will end in 24. Therefore, I can, and 2 to the power 7 is nothing but 128. Therefore, this simplifies to 24 into 128. And remember, we are only dealing with the last two digits. It's not the whole answer of 2 to the power 97. We are just trying to find the last two digits of 2 to the power 97. Alright, from this part over here, we have got that 24 is the last two digits, and over here 2 to the power 7 is 128, but last two digits only depends on last two digits. Therefore, we just need to take the last two digits, that is 2 and 8. Now, I just need to multiply 24 and 28. So 24 into 28, that gives me 672. Therefore, the last two digits of 2 to the power 97 is nothing but 72. Let's discuss questions of the form a to the power b. When divided with 100 or 50 or 25 or 20, what's the remainder? Now remember, when you divide with 100, 50, 25 or 20, the remainder depends only on the last two digits. Remember, these 100, 50, 25 and 20, they are combinations of 2 square and 5 square, right? Now, what do I mean with that? Let me keep this aside. Say you have a number 24782. The expanded form of this number is 2 into 10,000 plus 4 into 1000 plus 7 into 100 plus 8 into 10 plus 2, right? Now you can observe that 10,000, 1000 and 100 are divisible by all these numbers, right? They are divisible by 2 square and 5 square. If you take any combination of it, it will be divisible by them. So just see over here, 100 is nothing but 2 square into 5 square. Similarly, 50 is nothing but 2 into 5 square. 25 is nothing but 5 square. 20 is nothing but 2 square into 5, right? So they are just combinations of 2 square and 5 square. You can see that whenever you have these numbers in your as your divisor, the remainder will depend only on the last two digits, because over here your place value is 10, over here your place value is 1, and these are not perfectly divided by 100, 50, 25 or 20. Therefore, for finding the remainder, you just need to check the last two digits. Alright, let's keep that aside. Say you have a question 24782 divided by 100 and the same number divided by 50, the same number divided by 25 or 20, 4 and 5. Alright, now this expression over here is the same as 82 divided by 100 and taking the remainder, because only the last two digits will matter, and this comes to 82 because it goes 0 times. So 82 can be written as 0 into 100 plus 82. What about this case? This one, when you want to find the remainder, it's the same thing as 82 by 50 and taking the remainder, that's 32, because 82 is 1 into 50 plus 32. Similarly, over here it's the same as 82 by 25 and taking the remainder. So 25 into 3 is 75, 75 plus 7 is 82. So your remainder over here is 7. Similarly over here, that's 82 by 20 taking the remainder, that's 2, because 20 into 4 is 80 and 80 plus 2 is 82. So you have your remainder as 2 over here. Over here, that's 82 by 4 taking the remainder, and you will get the remainder as 2. Similarly over here, in the case of 5, you just need to take the last digit, because you can see that even 10 is perfectly divisible by 5. So 82 over here, you just need to do 2 by 5 remainder, right? And if you do that, you will see that your answer is nothing but 2. Now remember, you may have a question where you have to first find the last two digits. Like for example, if you are asked to find 13 to the power 792 divided by 100, what is the remainder? Now in this case, you need to combine this along with the previous technique. So you need to first find the last two digits. That's the step 1. Find the last two digits of 13 to the power 792, and once you have the last two digits, you just need to find that number divided by 100 and take the remainder, just like we did over